Hello everyone, my topic is about the structural health monitoring, a smart sensor integration for the building safety. My research proposed a real-time structural health monitoring system using the smart IoT sensors to detect any of the damage in the building by checking its temperature, its humidity, its vibration, its structural behavior. This system also detect both the linear and the non-linear damage. By this system, both the current health of the structure as well as the future performance can be detected. The next is the key sensor technology which I have used. The first one is the accelerometer and the gyroscope. Second is the thermal comfort sensor and the environmental sensor. The use of accelerometer is that it measures the vibration, the shocks and the acceleration, which is helping us to spot the things like any of the natural movement in the building or any unaccepted bumps. The second is the gyroscope. The gyroscopes measure how the structure is spinning. For example, if there is any twist or any tilt or any shift in the building, it measures that. The use of the thermal comfort sensor is that its sensor is used to measure the indoor air temperature, the humidity, and the air speed to measure the occupant comfort. And the environmental sensor is used to particularly monitor the internal condition, which can lead the uncertainty in a building for a particular part or the whole building, which can affect the building, and it helps us to identify that lead of the building which faults due to the structural derivation over the time. Next is the understanding of the structural health monitoring. The first one is the definition. That for example, SHM is the development and the implementation of a system for the continuous supervision and the maintenance. Means we need a system to continually supervise and maintain a building for itself. For example, if there is a building of 50 years, we can at an interval of every 2 years we can scan the building and check that if there is anything no wrong, for example, or any shift or any natural movement which can cause the public safety and lead and mislead the use of public awareness and can destroy the building health. The second is the types of damage detection. There are two type of damage, that is linear damage and the non-linear damage. The linear damage is caused when the structure continues to behave the same after being damaged, and the non-linear damage affect the way the structure act. For example, that the SHM uses a different damage detection to evaluate the techniques for the vibration response. The third is the modern challenges. The building can face the multiple factors like of the natural disaster. For example, any earthquake can happen and cause the building effect, or any sudden crack which can be harmful for a building. The next is the literature review section. These are the four main paper which I had cited for the use of this report by extracting the information that what is the advantages, how the what is the flow of how to detect the health of the building, the use of the sensors, how particular sensors are used for the data transmission, the data collection, then the notification system. These are the key findings and the focus which has been shown in this. The next is the system architecture, the data flow on the component. The first one is the data sources. That is the sensor which I have used. That is accelerometer, gyroscope, wireless smart sensor, thermal comfort sensor, environmental sensor, etc. The second is the data capture protocol, means where the data is to be transmitted or the collected. For example, the MQTT protocol. It is the best protocol for the real-time data capture. Then the RF communication. RF means the radio frequency communication. It is used for a long or short distance communication. Then the WebSocket for the communication and HTTPS for the standard data transmission. Then we come up on the data storage. If the data is transmitted, then there should be a place where it should be stored. That is the cloud storage on the local storage with the time span in the CSV or JSON format. The fourth one is the notification system. For example, at a sudden time there is an earthquake happen at that a particular building, and we can see there is a crack in the building and which can affect the building health and the public safety. Then the sensor will detect that crack and send a notification or an email to the stakeholder by telling them that this part of the building is affected, please see it. The next is the microcontroller integration in the processes. There are four types, that are cloud analytics, viral communication, microcontroller, and a smart sensor. The main difference that is between a smart sensor and a typical integrated sensor is about the intelligence, that how the microprocessor is a part of a sensor and how it is working. For example, the Arduino Uno and the Raspberry Pi are the main microcontroller which are used for the building monitoring solutions and building health detection. The next is the cost, that we have taken an estimated cost of $1,650, in which we have used 20 IoT sensors, the 8 microcontrollers, and one cloud platform. And at the end, now telling about the conclusion, it is that the SHM system embeds the smart sensor, the wireless connectivity, the cloud-based storage or the local storage to allow the real-time data monitoring for the health of a particular building, and it's by seeing its environmental condition, the natural conditions, which can effective and using of the effective protocols from the data like the accelerometer, using of the accelerometer, gyroscope, my smart sensor, the thermal comfort sensor, the environmental sensor to detect the real time monitoring and storing it in a cloud or in a local storage. Thank you.